Now we're going to talk about subsets. So a subset is a set that is part of another set. So in other words, B is a subset of A if and only if every element of B is also an element of A. One way that we can describe this is like with circular kind of sets. So I could say if this is set A, then set B is inside of it, and everything inside of B is also inside of A. That's what it means to be a subset. So this is the way we denote it, and we use this weird, it's like a little C with a line underneath it. Well, that C with the line underneath it comes from this symbol, which means less than or equal to. So this means less elements, or it could have the same number of elements. That's what this comes from. So think of it as like a less than or equal to sign, a less than or equal to sign. If B is not a subset, then we just put a slash through it. We say it's not a subset. Now, two things you need to know. If two sets are equal, they are automatically subsets of one another. So if A is equal to B, then A is a subset of B and B is a subset of A. It goes back and forth. The null set, remember that's our empty set. We can write it like this. There's our empty set. It's a subset of everything because it has no elements. So it's always going to have less than or equal to the elements in the bigger set. So the null set is like a gimme. It goes with all of them. It's one of the subsets. So here I've given you 5 sets. They all contain numbers. Some have 3 elements, some have 5 elements, some have more than that. Some have 6 elements. And we want to know, are the following subsets of A? So notice all of these are paired up against A. So A, he's kind of the big dog here we want to look at. He's got 0, 1, 2, 3, 4, and 5 as elements. Okay. So we want to know, is B a subset of A? Is every element in B also seen in A? And 0, 1, and 2, those are all inside of here. So B is a subset of A. All the elements in B are contained in A. Now let's look at C. C has 1, 3, and 5. Are those all inside of A? Yes. So that's a subset. C is a subset of A. How about D? D has 1, 2, 3, and 6. Are all of those elements inside of A? Well, no, 6 isn't. He's kind of the problem child. So D is not going to be a subset of A because of the 6. And then what about E? E contains the exact same elements, 0, 1, 2, 3, 4, 5, and A is 0. So they're actually equal to each other, but that means that E is a subset of A. So E is actually equal to A. We could also say A is a subset of E. Since they're equal, all 3 of these relationships would hold. But yes, you can have the same number of elements, that's the equal to, or you can have less elements to be a subset. So now let's practice writing out all of the subsets of a set. So I'm going to start here. My paper all lined up. So it says list all possible subsets of the following set. This is set X, and it just contains the numbers 5, 7, and 9. So it's got 3 elements. So we could say the cardinal number of set X is 3. So when we create all possible subsets, I think if we could be really systematic about this, that would be the best. So I'm going to do all of the subsets that have no elements, and then all the subsets that have 1 element, and 2 elements, and 3 elements. So I'm going to kind of go in order. So for 0 elements, the only subset that has 0 elements is your null set. So there's my null set. Or you can write it with the 0 with the slash through it. Now let's write down all of the subsets that would have 1 element, just a single number in the subset. Well, we could have 5, we could have 7, or we could have 9. Those are all of the sets that have a single element in them. See, 1 element in each. I'll call these guys the singles. Now let's do the doubles. How many subsets can we write that have 2 elements? Well, I could pair up 5 and 7, or I could pair up 5 and 9, or I could pair up 7 and 9. If you pick any other pairing, we've already mentioned it. So don't say 7, 5, because that's the same thing as 5, 7. And don't say 9, 7. That's the same thing as 7, 9. So we don't want to list any repeats here. There's just 3. We're going to call those the doubles. And now let's do the triples. How many have 3 elements? Because remember, to be a subset, you can have less than or equal to the same number of elements. So this would just be literally the original set. And if you change the order, it's not a different set, so don't bother changing the order. Just leave it like that. So how many possible subsets do we have? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 subsets that can be created from these 3 elements. Well, wouldn't it be nice to know like how many subsets you were going to come up with? Like maybe you have 4 elements and you're like, man, how long am I going to have to go? Like how many subsets are there going to be until I'm done? There is a quick way, and I knew before we started this problem there was going to be 8 subsets. So how did I know that? Well, we're going to develop a little formula here that's going to tell you how many subsets there are for a set with a certain number of elements. So we're going to start it off with like a table here. How many subsets can be made from a set containing n elements? We're going to start off nice and easy here. We're going to start with 0. If there are no elements in the set, this is literally the empty set, then I'm going to write the subset like this. The only subset of the empty set is just the empty set. I mean, it's not terribly exciting, but there is only one subset, and it's the set itself. Kind of boring. So what if your set has 1 element? So maybe it looks like this. Maybe it just has the letter A. Well, you could have the null set, that's the no elements part, or you could list all of the singles. Well, all the singles would be just A, that's the whole set. So you'd have 2 subsets that were possible. The null set, and then any singles. Remember, if you'll think of it as none, singles, doubles, triples, then I think that might help you stay kind of in line here. So we've got the none and we got the singles. We only have 1 element, so we can't do doubles or triples. So what if your set has 2 elements? So what if your set is like this, A, B? Maybe that's our set. Well, we'd have the null set, and let's list out all the singles. The singles would be A by itself, and B by itself. And then the doubles would be A, B, and we can't go bigger than doubles because we only have 2 elements. So that looks to me like there are 4 subsets that are possible. So what if you have 3 elements? Like, for example, 5, 7, 9. Okay, so like I'm not going to reinvent the wheel here. I'm going to say, see example at the top of the page, right? So if we go up there and look, if you have 3 elements, 5, 7, and 9, we had 8 subsets. I'm not going to write them down again. We did the nones, the singles, the doubles, and the triples because we had 3 elements. So it turned out there was 8. That's what I want to get from that one. So what about if there are 4 elements? Now this one, just for the sake of the length of time of this video, I went ahead and wrote them down for you. So we're just going to kind of go through them here, and it took me a couple lines to do it. But if we have 4 elements, and I called them A, B, C, and D, then I did the null set for my none. Here's all the singles, A, B, C, D. If I paired all those up, these are all the pairs we can get. AB, AC, AD, BC, BD, and CD. If you change the order, it's the same sets, so don't bother changing the order. And then I did the triples. Here's all the groups of 3 I could get. And then I actually had a quadruple on this one because we had 4 elements. So if you add all of those up, it turns out that there are 16. So what we're trying to figure out is, what is this pattern here that's happening? This is the number of elements versus the number of subsets. So how do we go from the first number to the second number? You can see, hopefully, that here on the second column we're multiplying by 2. So times 2 times 2 times 2 times 2. If you had 5 elements, there would be 32 subsets. You would not want to have to list them all. Beyond that, there's a whole lot of subsets. So if we can figure out a quick way to do this, we're going to use exponents. So I'm going to write it like this. I'm going to say, if we write this as 2 to the 0 power, anything to the 0 power is by definition 1. What if I do 2 to the first power? I get 2. What if I do 2 to the second power? I get 4. What if I do 2 to the third power? I would get 8. 2 to the fourth power, I would get 16. So it turns out the number of elements is the exponent. So if your number of elements is n, there's going to be that many subsets that can be drawn, 2 to the nth power. So if you have n elements in a set, 2 to the n subsets can be formed, and that's definitely something you want to know. So if you have 5 elements, there'd be 32 subsets that could be formed, because 2 to the 5th would be 32.